first time to GroupBy, but okay, better late than never, you know. Anyways, so first of all, thank you again for joining us. Um, where do I click here? Oh, the GroupBy code of contact. I'm not gonna explain all of this. I'm sure many presenters before me already have. And for the full policy, you can go to groupby.org/code of contact. Thank you also for all of the sponsors, without whom this would not have been possible, I presume. And we're going to start with our session for today, for now, at least for this slot, Advanced Dynamic Search Queries in T-SQL, the Ninja way. A few words about myself. My name is Eitan Blumin. You can also call me Ethan if you feel like it. I'm a DBA team leader at Madeira Data Solutions, which is a consulting company for the Microsoft Data Platform situated in Israel. You can see on the screen the address to our website. I also have my own personal website, my own blog at eitanblumin.com. And I am also a co-host of the SQL Server Radio podcast together with Guy Glanzer, who is also from Madeira Data Solutions. I'm also active on Twitter, on Facebook, and LinkedIn. I've been a SQL Server DBA since the year 2005, a consultant, senior consultant at Madeira since 2010, and I'm a data platform MVP since 2020. Okay, so before we start, I just want to stress that everything I'm going to show you today is available as open source on my GitHub repository. Actually, I think I moved over to the organizational Madeira repository, but the link will take you there anyway, so it's okay. At github.com/eitanblumin/dynamic filters. github.com/eitanblumin/dynamic filters. Before we start, a few prerequisites, hopefully that I hope most of you, if not all of you, are familiar with. So you should be familiar, at least at a basic level, familiarity with dynamic SQL, parameter sniffing, and SQL injection. Unfortunately, I don't have enough time to go in depth into each of these topics. We want to move forward. We are beyond these points, okay? So first of all, let's start with a true story. So once upon a time, I had this customer that they had something that looked like this search screen over here. Something like on like the same style, which basically means that they had a search screen where the user, the end user, could filter on each of these or each of several columns, and there was like a single option to filter per each column. For example, there was a text field that you could that could be used for like contains or like percentage search. There were numerical columns that you could filter based on range, or same thing for date columns maybe. And maybe a few columns that could receive like a list of values if it's something, some sort of a lookup, for example. So this is a very common use case where an end user wants to filter on a set of data provided by the organization, by the company. So let's start with that to understand this as a sort of a starting point, okay? How would this sort of thing be implemented, usually at least? So the most basic way to implement this would be using basically SQL injection, which is the part of the top, right? Is the thing that you see at the application level, be it C# or Python or the VB Node, whatever it is, and you see the parentheses and 0, parentheses and 1, parentheses and 2. Those are the parameters provided by the application level. And those get translated to what you see at the bottom, which is what the SQL Server side receives. This is the request received by the SQL Server. This is obviously SQL injection. It's very bad for security and sometimes for performance. So the most common way to resolve this is by basically parameterizing the query, which instead of injecting the values themselves into the command, those values will be delivered as parameters, right? Like P1, P2, P3. This is the sort of thing that we often see with ORM systems, such as Link4SQL, Entity Framework, and Hibernate, and so on. If we were to implement the same thing using a store procedure, where the logic basically is taken care of by the SQL Server itself, then we would see something like this, like a store procedure that receives optional parameters, optional as in by default they get a null value, and the query that is executed has this is what's called the kitchen sink, right? Where a single query has all of the logic already implemented in it, where it queries from, let's say, members in this case, and at name is null, or name, the column name contains the parameter name. Same thing for filtering by country, filtering by range, date range, and so on and so forth. So the problem here is with execution plans. So most of the time, it is reasonable to assume that most of the parameters would not actually be provided. Maybe there will be some parameters that are more commonly provided compared to others, more frequently provided, or there could be like a very high variation between permutations, combinations of parameters that are provided by the end user. And we would have like an issue here with the execution plans not being created optimally for each specific use case. The common way to resolve this would be to use the option recompile clause, which basically forces parameter sniffing at runtime at the statement. And then since the SQL Server engine knows exactly which values are null and which are not, it knows to create a very focused, very specific execution plan for that specific use case. The downside is the recompiles themselves, because if this store procedure is very, very frequently used, for example, then all of these recompiles could have a very heavy CPU overhead. They have a price, cost, I mean. And also basically you don't have the execution plan retained in your procedure cache, your SQL plan cache, and so on. I see. Is there a question? Something is.
No, they were asking about the URL for your GitHub repo, but someone posted it, so it's all good.
Oh, the original link return 404. Oh, that's weird. Okay.
Yeah.
I guess there's like a timeout.
They usually redirect, right?
They did.
Yeah.
I promise you that they did. Maybe there's like a timeout for it when it gets too old. Okay.
That means I have to revise my code.
Definitely, yeah. Yeah. I'm gonna have to update my presentation for sure. So instead of Eitan Blumin, it would be Madera data. I'll come back to it later, so I'll fix it on screen. Okay. Right. So the common way, the proper way, the best practice way to resolve all the problems that I just mentioned is to do something like this. I swear I clicked on my mouse. There it is. Okay. Which basically means to create dynamic SQL. We dynamically construct a command using text strings. And instead of the query itself as a query, implement the logic of if it's null, then ignore, otherwise filter by it. This same logic will be implemented by the T-SQL, that wraps around the dynamic query. For example, if name is not null, then concatenate to the dynamic command the filter for the name column, and so on for the rest of the columns. And then we would use SP execute SQL to execute the end result of the dynamic command, and deliver, move forward the parameters themselves. There's no issue here to pass over all of the parameters, because even if some parameter is not used, it's not a problem. So here we also avoid SQL injection because we only use parameters. And we also avoid option recompiles because each, let's say, unique permutation of parameters has its own plan. For example, the result command could look like this: select from members when blah, 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 name equals parameter name. Or it could look like this: select from members where blah, 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 country equals country, and registration date larger than the parameter. So each of these separately would be stored in the plain cache as ad hoc queries, but they will still be stored and they would not require recompile every time it's executed. But this is what they actually wanted, the customer, right? They had problems with the previous method. It was not good enough for what they needed. They needed something which is even more dynamic, not just a single filter type per column at most, but even more than that. Maybe instead of filtering just contains operator on the textual column, we also want to allow the end user to choose, okay, I want it to be equal exactly, or maybe starts with, or maybe ends with, maybe not equal, and so on. Maybe there are all kinds of other parameters that could be relevant for, other operators that could be relevant for different parameters. For example, in, not in, larger than, greater than, smaller than, so on. So there's a wide selection of possibilities, and the customer wanted to give this flexibility to their end users. This would not be possible using the previous method. Why? It's not possible because there are a few limitations that cannot be resolved using the previous method. First of all, the number of parameters is limited. It doesn't matter how you look at it, the number of parameters that stop procedure can receive is limited. Maybe you can add 100 parameters. It's going to be a pain in the head to maintain it, obviously, but it could be possible. But at some time, you're going to hit some kind of glass ceiling, right? And the operator type per each parameter is either fixed or it's limited. And for example, what I said previously, like, contain, starts with, ends with, equals, not equals, in, not in, greater than, smaller than, and so on. Either you would have to use some kind of dynamic SQL, like get the parameter as an input from the end user, which then you get the risk of SQL injection. Or you account for all kinds of possible permutations and combinations, and you just create 50,000 parameters for your stop procedure, which is, let's be honest, it's impossible to maintain. And every time there's a change in the schema or in the options that we want to present to the user, we have multiple layers, multiple points of maintenance that we need to change. We need to change the front-end GUI, the graphical interface that the user received, because we need to see the new option available in the interface. We need to change the business logic layer that receives the parameters from the GUI and then executes the stop procedure. If there is a new parameter, you need to change the business logic to account for that new parameter. And obviously a change in the database, the stop procedure itself also needs to be maintained, adding or changing parameters and so on. So in order to resolve these limitations, we should first really understand the problem. Okay, so first let's set up a few definitions, a few terms, basic terms that we would use throughout the presentation, and we could follow. So let's look at it like that. A literal value, which we'll mark in the color red, is the value that we receive, the actual literal value that we receive from the end user. For example, the user filters for first name John. John is the literal value. Parameters, which is marked as orange or yellow, I'm not sure, it depends on which screen you're using. That will be the parameter itself, the one starts with the strudel, right? Like a strudel name, that's the parameter. A parameter collection, which I mark in the color green, that is the set of one or more parameters. For example, in the previous examples, the store procedure itself is a parameter collection, parameter set, okay? So let's remember those terms, save them here at the side, and then see a few examples. So the basic, the first example that I gave here, the one with the SQL injection. So here you see in yellow, we have the parameters. In red, those are the literal actual values received from the end user. And you're probably asking yourself, what is the parameter collection here? What's the green part? So all of this is the green part, okay? All of this serves as the collection of the parameters. Let's take the example of the dynamic SQL, the store procedure with the dynamic SQL. So here we don't have the red part, except the red text string because I copied it from Management Studio. But anyway, there's no literal value here that is concatenated to anything. We only have the yellow colored parameters themselves, and the store procedure itself serves as the parameter collection that we need to maintain. Okay, so let's look at our layers now. Our layers is, as I said, the graphical interface, the business logic, and the database. So at the graphical interface, there will be some kind of function that would, like a method or some sort of call that would trigger basically the business logic. So we need to move to pass the parameters provided by the user over to the business logic. So that's, let's say we have like a search form. So it's frm.name and then frm.country and so on. At the business layer, as I said, we need to receive all of these values from the GUI and then add them as parameters to the store procedure. And then at the database side, we have the store procedure with the parameters. And each of these separately is a distinct parameter collection that needs to be maintained separately. Okay, so we have this problem in front of us. How do we resolve it? First of all, a few ideas maybe from the crowd. I'll give you a few seconds. Maybe something at the Slack channel.
It's pretty quiet. I think people are still having their morning coffee.
Okay.
I'm going to be honest, I wouldn't know really how to package this in a stored procedure with anything less than making it very bloated. So I would guess you're going to dynamic SQL somehow. But
you're guessing
curious
correct.
to see how you're going to parameterize sort of the procedure call with it.
Yeah, so considering the issues that I raised, that I mentioned, and how I described the problem, most people should be able to get an idea of, okay, these are the problems. I think I know how I can resolve this, because our
Manish
main
says,
problem.
Jude says, construct the query in the app.
Construct the query in the app.
Yeah.
So instead of a store procedure, I mean, right?
I'm guessing that's what he means. Yeah. Yes, he says.
Yes. Okay. So that is a common scenario usually available with modern ORMs. I think it is possible. There is like, it's a bit difficult to implement it and implement this, sorry, on at the application level so that it will be easy to maintain. And also, it introduces a problem where you know what, I'll focus on it in the next slide, okay? So let's just move forward and then you'll see what I mean. Okay. So what we do is we add another layer on top of everything I mentioned earlier. We add another layer of abstraction, which I call, okay. So the layers below, they are the parameter collection and the parameters themselves. They are part of our code, whether it's in the business logic or the GUI or the database. Little values are provided by the end user. Now we add the abstraction layer, which I call parameter parser, for example, which is our blue nifty little dancing robot here. And once we add this abstraction layer, which would be code, the layers below can become now data, not code, data. Now our parameters, parameter value, the collection of parameters, the data types, their names and functionality, they don't have to be part of our code base. The code base as in we need to maintain our code base, we need to deploy versions of our code base and change the code, whether it's even if it's the application layer, right? Where the application constructs dynamically the commands. What if we change something there? We need to deploy a new version, right? That could mean downtime, that could have other implications and so on. But once these parameters are data, then the whole solution becomes data-driven. And our main effort would be just to implement this parser layer once, just once. It could be tough work, but it's possible, and we do it once. We do it well enough, and then that's it. We don't really have any maintenance after that. We just change data because the data is driving the code. So we'll place our little friend here at the corner and see how it works. So we have our 3 layers, right? Let's say, as I said, our parameter collections and parameters, there would be data. So naturally, they would sit in our database where the data is stored. So that's the list you see, the green list at the right, with the list of parameters, basically. So this list, in some form or another, needs to be passed over to the interface, okay? The interface gets this list, which looks, let's say, something like this, like a JSON collection of data of which are our filter columns, what's their name, what kind of operators they're supporting. Operators as in equals, not equals, contains, starts with, so on. If it's a multi-value operator, then we also need a list of possible values. And you see the operators at the bottom, equals, not equals, contains, in, and whether each one is a multi-value or not. Once the GUI has this information, it can dynamically construct the search form, actually, right? Once we do that, the user provides the values. Those values are also packaged in a collection. Now it's not exactly, it's sort of a collection of parameters, but more properly called parameter value collection, okay? So for which columns we provide which parameters and which value or values. This data is then delivered over to the database level where all of our data is located. We don't even need any sort of logic at a business layer at this point. We don't need any sort of parser. We just get this collection of parameters, pass it over as is to the database layer. And then once the database has this a set of values provided by the user, and on the one hand, and on the other hand, it has let's say call it the metadata, right? Which is the columns, the list of columns, the list of operators, needs to combine everything together and then dynamically construct the query, which working, dancing, and looks something like this, which is, and everything you see here is dynamically constructed by this parser. Okay, so the what I marked here in blue, these are basically the way of the parser to reference each parameter provided by the user. Notice there is no concatenation here of actual literal values. All of these parameters are passed over from this single parameter collection provided by from the GUI, from the end user. So there is still an issue here, because the way to execute is let's say using execute SQL. We have this command, the one in the box, text box at the top. That's our parsed SQL. We have the params collection, which is the collection of parameter values provided from the end user, and that's it. But now we go back to one of the previous issues that I mentioned about parameter sniffing, right? And execution plans, or parameter sniffing, I mean, because here, if you notice, the parameters are declared locally, because they are constructed dynamically as part of the command, the main command itself. The declare P1, P2, and so on. Those are declared locally, so SQL Server cannot sniff those parameters unless you add, let's say, option recompile. But then we go back to the previous problem, right? Where if we have too many of those running, then you can have CPU overhead. So we could solve it by going one layer further, going even further down the rabbit hole, and do it like this. So we have like two sets of dynamic commands. One dynamic command constructs the parameters, the declares of the declares, and the passing over of these parameters to the sp execute SQL command. And another command is the query inside the CMD, right? And then its execution will look like the one below, where we have to pass over not just the parse SQL and the params, and we also need to pass over the command itself and the CMD params. Okay, so that's the CMD params is that's the declaration. It's a weird R, just build it out. And the declaration of the parameters as part of the execute SQL procedure itself. So we have a few requirements here in order to make this work. Requirements from these params, this certain specific strudel params parameter that we receive, all this thing that we get from the GUI all the way to the database. We have a few requirements from it. We need it to be able to store multiple values, possibly complex values, and we also need it to be able to we need to be able to access each parameter deterministically. So that when we construct all of these declares and sets, we would be able to determine that, okay, this declare is for parameter 1, and the value that it needs to get needs to be received from parameter 1. We need to be, to be able to connect between these two deterministically from the parameter and its value inside. So SQL Server provides several functionalities that several data types that can give us this functionality. We have XML, we have JSON. We can also use table value parameters. If you want, I suppose you could also implement something of your own using CLR, but I honestly don't see a reason to do it. I think the previous options are more than good enough. Each one of these gives us exactly this solution. We can store collections, even complex collection of data, we can reference each value inside of this collection deterministically. And it is all packaged as a single parameter, obviously. So let's review. When we do use the data-driven abstraction layer, then the graphical interface receives metadata from the database and uses it to generate dynamically the search form for the end user. The business logic receives a single object, which holds inside the collection of the parameter values, and uses it to execute the store procedure at the database layer using a single parameter. The store procedure then passes this single parameter or the collection inside and dynamically generates the necessary command. Without this, the GUI has to be hard-coded and maintained, at least at some level, if not entirely. The same thing with the business logic. It needs to execute the store procedure with multiple parameters and hard-coded, and that could have the same problems of maintainability. And the database store procedure, again, can dynamically generate the command, but it is based on hard-coded logic and a finite set of parameters. So with your permission, let's see a demo, okay? So before we do, just a small preface. I am not a professional web designer, okay? And this is sort of a hobby of mine that I used to have about 10 years ago. So I had to like kind of sort of learn it on the go. So what I did is very, very basic level, okay? But it works at least for the purpose of this demo. So
I think that's how we all got started.
Yeah, I guess that's true. So this is what my demo app looks like. We have, let's do it like this, make it smaller, and then I'm gonna zoom in. So yeah, do it like this. That's okay, right? Okay, so we have, I have like a starter set of parameters just for the demo. For example, I want to filter on first name. The operator type is contains. This is the value I want to filter on. And I can also specify first name again. This time I want to filter ends with, and then A, for example, doesn't matter, right? I want to filter on country, where its value is in Israel, USA, or France. And I want to filter on registration date and time to be greater than whatever, okay? Once I click on that, wait, before that. So all of this at the GUI level is represented as this JSON, okay? These are our columns. For each column, the operator, the value, or values, where is it? Or values, right? We send that over to the database. I have a store procedure that takes care of all the calculations, and I get a response. Response looks like this. It's also a JSON with all the values and so on. Obviously, I can tweak it a bit. This is not a static page, right? It actually works. So let's say, for example, registration, let's say first name, no, let's say last name. What do I have? Some kind of example. Let's say last name contains May. Let's add that, search. And as you can see, it affects the filtering. Okay. And I can add as many of these parameters as I want with as any sort of combination that I want. Let's say not equals, let's say, let's take an example here. This is country ID 1, which is, if I recall correctly, that's Israel. So I don't want Israel, not equals Israel. Search. Where's the tooltip? Oh, it is. And that's country, where is it? 4. So you see the one I had before just disappeared, okay? Or if I want to, let's do something funny here, where country also equals Israel, obviously that's not going to be, no, not going to return anything, just for the laughs. Okay, so let's look at how this looks from the database side. Okay, so I want to create like a very basic profile trace here. Let's search this again. And this is the value, the command that was captured. Wait, what does it look like this? Oh, okay, this is the one I want, yeah. Filter, yeah, that's this one, and this one. Okay, this is what the application sends over to the database. I have this store procedure, which is responsible for parsing everything. It says which table I want to query from, page size, and so on. And this is the params collection, right? So we have everything here. And once this runs, obviously nothing is drawn because I want to have something that cannot be possible. Let's try and manually remove this thing here. Okay. So we have the result, and this is the output command, right? This is the parse SQL command. So this is what it looks like when it executes the query itself in actuality. We have the declarations, whoopsie. We have the declarations, and for each parameter, we set the value using OpenJSON to access the value from the parameters collections, and so on and so forth. Paging, if I want, I can also add option recompile here, and also do the nested execution if I want. Where is it? If I recall correctly, I have a parameter for that. No, okay, maybe I have an older version of here. Doesn't matter, okay. Where is, okay, so now I want to show you the metadata tables. So we have three metadata tables: filter columns, filter operators, and filter tables. So each column, filter column, belongs to a single certain table, right? It can have an alias and an actual name. You see here, the table name here is not actually members, it's actually fields from a view. And which the column, the data types, and all kinds of options and supportive operators. And if it's a multi-value column then we can also use like a command like this, save the command that is responsible for retrieving the values. So that too is data driven, this setting.
This is really neat. I was just going to ask if you do the validation of the parameters and everything in the stored procedure, but you're looking them up dynamically in lookup tables. That's even next level. That's not
Yeah.
really nice.
Thanks. And this is also sort of next level because I have the list of the operators here, and I can also create new operators and define for them like a sort of an, let's call it a template, right? Where we can, we have like the column and the parameters, and something is happening here. Like there needs to be some sort of logic. So this logic is implemented using this dynamic SQL template, basically. Cool.
Very cool. Yeah.
So using that sort of solution, what have we achieved? The number of conditions is unlimited, as much as the user wants in any combination, or at least as per the limitations defined by those metadata tables that I just showed you. We can have multiple operator types per parameters. We have only one single point of maintenance, which is the data itself, those metadata tables. And despite all of the dynamic capabilities and flexibility of the above, there is no SQL injection. There is kind of sort of SQL injection behind the scenes, but not involving anything that is received from the end user. And that's important to remember, right? Because I have dynamic SQL here, I have SQL injection, but all of this injection is dependent on the metadata tables that let's say the administrator, right? The developer provides for the database. So the danger does not come from the end user. It could come maybe from the developer, right? But not from the end user. So now what? You can go ahead to the GitHub repository. I'm going to show the link again on the screen and fix it. Review and study the store procedure responsible for parsing the filters. I'm sure you find it very interesting. Or you can build your own if you feel like it based on your understanding of this session. You can go to your developers or product managers and tell them that you have a nice surprise for them, that you can provide very nice, very cool flexibility for the end users that may not have been easy to implement until now. And the next step after that is to prepare for the impending disaster of your end users going wild and abusing your tables and indexes because they want to filter on everything in every possible combination. But that's a topic for another time. So the source code is here, and let me just take a second here to fix the link. So that's the correct link. Go ahead. github.com/maderadata/dynamic filters. And if you want, and now is the time to also ask questions, I guess. And if you want to, you can also stay in touch. My details are on the screen, my email, Twitter handle, LinkedIn, blog, and so on.
So there is one questioner from Jiri who says, won't parsing the parameters from JSON at the database level be a performance bottleneck? It is said that parsing at this level is the least efficient way and costly. And he references to licensing costs for a SQL Server.
Yes, I get this question a lot, and I want to stress that it's true, but only in the sense that it depends on the size of data provided by the end user, right? It's not a data size operation as in the amount of data that you get from the tables themselves that you query from, but only dependent on the size of the set of parameter values provided by the end user. Normally,
and I guess
wouldn't be too much, right? A user could provide only so much, right? If I guess theoretically, if an end user want to be harmful, they could, just bombard this parameter collection with as many values and parameters as needed in order to crash your server due to memory allocation and so on. I guess you could implement some sort of like a fail-safe for that. Just like check the size of the parameter at the business logic layer or the GUI even.
Right, I would probably add something in the business logic to just limit the number of parameters you can search or something like that.
Yeah, either that, limit the parameters, although that will be kind of complicated to implement, like do something like a top, but maybe just as a fail-safe, like check the size, okay? Because let's be honest, the real issue here is the size of the parameter. So maybe if it's large, something like very unreasonable, right? I don't know, like 20 megabytes or more, right? Then I would assume that it's reasonable for the business logic to say at this point, okay, something is suspicious. Just don't pass it over, okay?
I was helping a client a couple of years ago solve exactly this type of problem, but more from a performance tuning standpoint. And when we sort of dug into the solution, it turned out they just did a select star, moved the complete data set up into the web, and that's how they did. They could sort of search in a drop down, and all the data was already cached in the browser. So the client side performance was terrible. Database was pretty good, but they just moved like 10 megabytes up to the web browser, and like here's all your clients. You can do whatever you want with them.
Yeah, I think Trello did that a while ago.
Oh wow!
Yeah,
that's nice.
There was an issue with something like that with Trello. I recall.
Yeah,
I think they improved it since, but they had this problem where if you had too much data on screen, you could filter it. It would be, it doesn't need to go to the database because everything is already in your browser. But then it would crash browsers.
I'm going to be honest. I haven't worked with that large of a Trello board ever. I think I'm going to say most of my boards are less than 100 tickets, but
yeah, but it happened. Yeah.
Yeah.
So there's a comment here from Michael. Data search will be way more expensive than parsing parameters. I'm not sure how that's true because
yeah, I think that's a response to Jiri's question about parsing JSON.
Oh yeah, okay, I get it. Yeah, that's true. Yeah, at least relatively. Yeah. Any more questions?
I don't see any.
Yeah, sorry if I'm bumping in, but I have a question for you, Etienne. So this ties in very much to a presentation that I have, but which is sort of the pre-cal to this presentation. So I don't know exactly how will this recording be available? Will they be on YouTube or something like that?
We're going to put all the sessions on YouTube. It's going to take my colleague Jeremy a couple of weeks to finish all the post-processing work, but all of these recordings are going up on YouTube on the GroupBy channel.
Okay, that's great. Because then I would like to have put into a link in my article and also in my presentation, because I have basically when I come to this thing at the end, I said, "Oh, this is better done in the client layer," and I might still think so, but I mean, still interesting to point people to a solution. If you want to do this, here is a guy who's actually done this in the database, so they can sort of get that. So that would be very interesting.
Yeah, I'm going to say it's a very elegant solution, very dynamic.
Yeah, thank you. I worked very hard on this. So about that, by the way, so the solution includes several variations of the stop procedure, the one that does the parsing. So I have 3 variations, actually 6, I think, maybe something like that, where 1 variation for XML, 1 variation for JSON, 1 variation for table var parameters, and another version of each, which implements the same logic, but with the nested execute SQL, which should resolve the parameter sniffing issue that we talked about earlier.
So there's a question from, sorry.
Yeah, I just want to say that all these are available at GitHub repository.
Aline says, I see that there's a demo web client folder on GitHub. Does it contain everything that's needed to fully understand how this works?
Yeah, the web client is the demo web app, basically. Yeah, it does. It has everything. There's a README on the repository with instructions for how to activate it and what's needed if you want to run it locally on your computer. But the main focus of this is actually the database side. As I said earlier, I'm not a professional web developer. I admit that I did not do this well enough, right? Also, I have this one time someone asked me about how would you do the same with complex nested conditions. You know what I mean?
Yeah.
So like and. So that's obviously that's a whole different level of complexity, especially from the application side. I tried. I did not know how to do this. I started fumbling around, but wasn't successful. A professional web developer would probably know how to do it much better than me. Either way, the focus here, as I said, is the database side, because
that's where the magic
happens.
let's be honest, what is the problem we're trying to solve if we're doing complex nested conditions? Is this some advanced type of report?
Maybe,
So,
I don't know.
I mean,
Yeah.
typically you're looking for customers or projects, or you're filtering on something for something. It sounds a little constructed to sort of.
Yeah, well, I think
guess.
there's like that gets to the level of like ERP systems.
Well, yeah, that's true.
Yeah, but yeah, that's a whole other level.
Awesome. So next session is, I'm going to check my calendar here. So Erland's coming up in 40 minutes, and we can all just shoot the breeze, or I can put up some generic slides, or whichever you want. So if there are any more panelists or moderators in, just feel free to enable your mics, or yeah. And thank you so much, Eitan. I enjoyed this presentation a lot.
Cool. Thank you
my
for
first
having me.
instinct is, oh, I'm going to rewrite this myself, but I don't have the time for that. But it's an awesome solution. I could have used this quite a few times.
Well, it's open source, so you can feel free to submit issues and pull requests if you want to improve it further.
Mm-hmm. I think my go-to solution whenever this kind of problem has showed up is just to say, no, you're going to have to settle for this solution. All equality conditions, just these are hard-coded things that you can search on.
Deal with it.
This is obviously a much more user-friendly and more elegant solution.
Yeah. Not necessarily database friendly, because as I said, once you give the end users this sort of power,
right, mm-hmm.
it has a risk, right?
I would probably put a top 100 in there somewhere.
Well, it's not necessarily an issue of top number of parameters. It's also an issue of the combinations that you have, mm-hmm. and the indexes that you have on your table. Because,
right. Mm-hmm.
Yeah, because if you have like this infinite number of combinations of parameters and columns that you filter by, then how can you even index something for something like that? You really can't.
Yeah.
Obviously, really. There is a downside in that regard. Yeah.
As I understood the SQL generate, you had a bunch of local parameters you more or less have to use option compile, which should not be much of an issue because many of these searches will be unique anyway.
That's possible. Yeah, that's also possible, because even if the structure of the command is the same, it is very much possible that the value passed over to the parameters could very much affect the execution plan, because it filters on different sets of data. Yeah, that's true.
I'm coming in from most of my work is on the BI side, so whenever a query takes more than a second or 5 seconds, it's not a big deal to me. So whenever you're in the territory where recompiles matter, where those milliseconds make a difference to performance, yeah, that's a completely different ball game, and I would probably be very careful giving people dynamic search conditions.
Yeah, I would guess that since this is something that is controlled by an end user, by a human person, right? It would not have this sort of frequency of execution that would require something like that.
Yeah.
Only if I would assume that the sort of frequency that would impact CPU overhead with too much recompiles would be something that has to be like a very high frequency that is computer generated, right? Like signals from an automated program.
Yeah.
Some kind.
Or a public website, I suppose, but.
Or a public website with millions of visitors.
Without a caching layer, because that's probably the first thing you would need to add to a public site. Yeah.
That too, yeah.
Yeah, I mean, for a normal sort of dynamic search where you only go by equal conditions, that one may also be used by some generic function in the background, for example, looking up an order by order ID, and then you can get this problem. Like that's very many calls to do that. But for this one, I mean, if you go and use this one also as a part of the business logic to, well, everyone comes in a new order, we're going to look this up. That sounds crazy. I would not expect option recompile to be an issue for this one, to be honest.
Yeah, exactly.
But I'm going to say is also, I have a client, it was quite a while since I worked with them, but I don't know how they implemented. They have these kind of searches. How they look like below, how they implemented, I don't know, because I didn't work with that part. But they were very, very dynamic, and the users, they loved it. Of course.
Maybe that's my client from 10 years.
Oh well,
I was going to say the same, but
I don't think it was.
It
was real estate. Well, or IC for real estate here in Sweden.
Oh, that's not okay. If it's real estate, then it's not the one. Yeah.
No, but I mean, of course, it's. I mean, you can do this in more way than once. I guess they had done their all thing client side, because as I said, that's how
that's the common one. Yeah, that's the common solution would be to do the same flexibility implemented by the application layer, the business logic, because there are ORMs that support this.
Or build an in-memory database somewhere on the application layer and use that to
yeah.
All depends on how much data you have. I mean, if you only have a small data set, you can do that. If you have, well, let's say 20 terabyte, maybe not.
Yep.
I mean, it depends on how many servers you can afford, right?
Yeah, it's true. And of course, if you have 20 terabytes, you probably need to nudge the user to use something that sort of, gives them an index.
Yeah, that's true.
I've just recently worked a project where I had to convince the API developers that you know, guys, if every query needs to run in less than a millisecond, you can't just make them up. You need to sort of carefully plan them so they align to the indexes and you know exactly what you want. You can't just sort of dynamically construct search queries and expect them to run in a millisecond. I'm going to have that discussion with them tomorrow again to see how that goes.
Good luck.
Okay, so here's the thing. The table is 200 gigabytes, and the reason your scan took 6 seconds as opposed to sub-millisecond is because... Are you writing this down? Yeah. I'm the cocky consultant guy. Everyone hates me.
I think it comes with the job.
It does. It does. It occasionally pays well too.
It does. Sometimes if you're not cocky, they don't trust you.
Oh, that could be one. That could be a point. Yeah. In the Nordics, we have a strong humility culture where you're supposed to be very, yeah. Nagi says, thank you for this, Eitan. I'm a big fan of SQL Server Radio. Great to finally put a face to the voice. Yeah, I've heard a couple episodes of SQL Server Radio and actually pushed the subscribe button just the other week. So I've started listening to a couple episodes.
Cool.
Love the podcast format just for, taking walks or doing other things while listening to something interesting.
Yeah.
Works out really well.
Yeah, it's also fun to do.
I imagine, yeah. And you get to interview all manner of interesting people as well.
Yep, sometimes, not too often, but sometimes we do. Yeah. Just last month we interviewed Anna Hoffman and Bob Ward. But it's sort of a rarity. Usually it's just me and the guy shooting the breeze.
That's the perfect format. Question from Andy. How do you use full text search to improve text search performance? No, do you use full text search to improve text search performance?
I guess you could. If you create like, where was it? A special operator for those sort of columns. Like you see this. So if you create like a new operator here with an operator template that implements the full text search functionality, I guess you could. Yeah.
And David says, thanks for the session on a mobile device as Zoom is banned at work. So it's a challenge to ask questions. You can ask your questions in Slack as well, David, if you want to have a long form question. Cool. So what say you all we take a 30-minute, we call it a leg stretcher in Sweden. It's a bio break, basically. I'm going to refill my water glass, and I'm looking forward to the next session, which is Erland Sommarskog in 30 minutes.
Yeah, and
Cool.
you will not get a 30-minute leg stretch after that session.
I know.
you can be happy if you get 5 minutes.
If anyone can talk about collations for 90 minutes, it'll be you, sir.
Yeah, I'll be trying to keep it within 75 minutes, but I'm almost maybe 76. Of course, it all depends on how many questions we get. We'll see. I'm
not going to push my luck. My first reaction was sort of when I switched to SQL, was it 2000 that introduced collations?
Yep.
I was like, what the fresh hell is this? And all my queries are breaking because I used different collations. I guess it was TempDB, I can't recall. But I still can't really imagine what you're going to fit into a 90-minute session. So I'm super looking forward to that one.
Well, turns out I could. Well, I think the original version I got down, I think the first rehearsal went to 97, and then I have to take this out. So yes, so I don't know it's difficult to say whether all you wanted to know about, well, it could be, as a matter of fact, I didn't tell you all, or it could be more than you ever wanted to know.
Accurate.